When we write a source code, our ultimate goal is to make it to deploy that onto a target environment. Whether the target environment is dev, UAT, staging, or prod, we need to make our source code runnable so it can run in the target environment. Hi, my name is Ali, and in this video, I am going to talk about the ultimate source to URL part. So in this picture, we have a diagram where I'm trying to depict the source code, which resides in a repository. Let's say it's a Git repository, and then some process happens in the middle. This process actually transforms our source code into a container image, so we can run it in a Kubernetes environment. And the reason we want to do that so that our end user can access and use the application that we have written in our source code. So in this video, I'm going to focus a little bit more, detail into the process part of this source to URL scenario. So the traditional process is we write a source code that resides in source repository, typically Git, and then we write a bunch of pipelines which converts the source code into a container image, and that gets deployed onto a Kubernetes environment. So, but there is few steps, there are a few things, and we have been doing this for some time now, which is perfectly fine. But there are, when we try to scale it and when we try to imagine this in a microservice or in a service-oriented architecture scenario, it's like trying to fit in a monolithic DevOps scenario, a monolithic DevSecOps scenario in a service-oriented architecture. And it starts to fall apart when we try to scale it. And when we try to add security and governance on top of it in the modern way. So there is some issue that happens in this picture. Please, if you are watching this video to learn more about the cartographer, please skip this section and please skip to the cartographer section. That's where I'll be demonstrating cartographer. But before I jump into the solution, how we solve this problem, I want to describe a little bit what is the actual problem. So in this picture, I'm using a Jenkins pipeline, and it could be a Azure DevOps or any given pipeline tooling as well. The highlight here is the concept of pipeline. That actually fails. So let's see how it actually does not work in our scenario. So let's focus on the challenge. So we have our source code, which is residing into Git repository, and we want to make it to the dev environment. Pretty simple. So we write a pipeline, we write a Docker file, and within the pipeline we define how to make a container image using that Docker file with the tooling called with Docker or some other tooling, right? Nothing wrong with that. It's perfectly fine. But then once our once we finish developing our application and testing it in the dev environment, right? At that time, we actually want to move this to a staging environment. So this is where things start to fall apart. So this is where this person or this group of people comes into picture called operator. And it could be like security and governance, or the group of or the team who is actually creating this pipeline and maintaining, or maintaining the environments, right? So they are responsible for making sure that what is making into the staging environment is actually compliant and secured, and it follows a certain path, so they can ensure the governance and security of it. So what they do, they give few Docker files and YAML files. Okay, so why? The Docker file that we had written for during our development phase, that Docker file may not be a compliant, industry standard compliant Docker file. It was something like we whipped up very quickly, and so that we can containerize our application ASAP, and actually progress with the development of the application. But now, come production time, we actually need to ensure that the container that we're producing, it's lean, it's coming from a secured base source image, and there are a few other things involved in there as well. And I'll demonstrate an example of it, so it'll be more clear at the time. And there's also YAML files. So these YAML files are the Kubernetes YAML files because the pipeline needs to deploy it onto the target environment, and also because it's a Kubernetes environment, there will be secrets that's involved in there, so that the pipeline can authenticate itself and then perform the deployment. So this is the staging pipeline that looks like. And we have a source, run, test. So for testing purpose, I'm using Gripe, but there could be many other testing tools like Sysdig or Trivi and so on and so forth, right? But this time, the container is getting built using the Docker file that got supplied by the operator. And the source code is getting scanned and so on and so forth. So it's a bit of a process, but that's okay. And then when everything is satisfied in the staging environment, we want to make it to the prod. Making prod is actually the operator guys is our friends, and we'll take care of it. So out of this staging pipeline, there might be a Helm chart that will get produced, and once the approval is confirmed, that Helm chart will be deployed to the prod environment. And eventually, like all the container images are inside container registry, so the Kubernetes will pull from there. Pretty simple picture. Now, when we try to scale this is where we'll see the real problem. So for application 1, we actually had 3 pipelines here. Now, when we start to develop the application 2, which is in a service-oriented architecture, all of this application will actually eventually make up to one giant function, right? So what will happen here is in application 2, we'll add 3 more pipelines following the very similar process. Now, just because I only had 2 environments or 3 environments, so that's why there is 3 pipelines. If I had more environment like UAT or integration, then there will be more pipelines associated with that. And not to mention the plethora of Docker files and the YAML files that I'll be adding, or I'll be getting from the platform operator to add to my source code repository, right? So we can see like things start to creep up, and imagine this in a scale of 50 to 100. This I can see how this can slowly become unmanageable. So here are the list of problems that will happen. So first, the problem is our pipelines are tightly integrated with our source code repository, right? So, and it doesn't scale. There's too many of them. So there's too many of them. There is infrastructure definitions that are added. There are several of them, and it's added to our source control repository. There's multiple Docker files, so that's an overhead to maintain. Then there is manual handoff. Like at some point, I'll need to tell that, hey, I want to make it to the production, and the operator will supply me this production file. So there needs to be a manual process involved in there. And the change of one component is hard. Let's imagine if I want to, if my organization says, hey, I don't want to use Gripe anymore. Organization-wise, we're going to use Trivi for our scanning tools. Then I have to change in all of these pipelines, right? And that's a problem. I will break things actually by doing so. And then there is security as well, because we are accessing the Kubernetes environment. There needs to be secrets, and the secret will in this picture will actually be within the Jenkins pipeline itself. Now, so that's a problem itself. That's number one. And the second is organizations usually have a policy of rotating these secrets every now and then, preferably once in a month or once in a fortnight. right? And that's where, again, we'll rotate the secret here. That means we'll have to record it in here against all of these pipelines. That is a massive security hole in this picture, right? So how do we resolve it? So one, we need to make it loosely coupled so that it's modular and reusable. So the whole concept of pipeline kind of goes away, because with the traditional orchestrated pipeline, you cannot achieve this to start with. Yes, master template will make it simpler, but again, there will be plethora of master template that will have to create in order to achieve similar pipelines. To achieve pipelines for multiple applications and multiple scenarios. So master template is great, but it may not achieve the scale that we want to achieve. We need to significantly reduce the infrastructure definition. That means no more of this, right? This is the Docker file scenario is not a big problem because there are tools that's available that we can get away from the Docker file and using the tool to containerize our application, so that's fine. Then the handover process needs to go away as well, because that's a choke point. Like there will be, if there are like many engineers who is developing many applications, the operation team, the central operation team, or even like each team has an operator, even in that case scenario, like this operation process becomes a choke point, so it cannot scale. If there is a manual handover process that's involved, that's a choke point right then and there, like to developing or delivering software faster and secure. So we need to get rid of that handover process, right? So enter Cartographer. So this is where Cartographer comes into picture. Cartographer introduces a concept called supply chain. It does not have a pipeline scenario. So one, it's event driven. So that means there is no tight integration with the source code. We'll achieve modularity and reusability with it because purely the way it works. So basically, as an operator, you will be writing a bunch of template files that will define the process of how to get the source code, how to test it, how to build the container out of it, how to deploy it, how to run GitOps, how to scan. That sort of processes will be defined in these templates. And then the supply chain is another construct that will get created, which will use those templates, will reference to those templates, so that it has one execution after another. And the executions also can be parallel because it's event driven, right? So let's say when in the supply chain of build, test, and deploy, what we can do is we'll add a source provider, which will point to our Git repository to get the source code in. And then once that job is finished or that process is finished, we raise an event. And our source tester will listen to that event. And it will complete the testing. The deployer will listen to the testing event. So once source tester passes, it'll raise a successful event with the URL of the source code, and the deployer will go ahead and deploy it, right? Or the image builder will be listening to it, and the image builder will make an image, and then deployer will be listening to the image builder that the image building is finished now. I'll go ahead and deploy. When come build, test, scan, and deliver supply chain, that will reference to the same source code provider, right? Now there is no tight integration with the source repository because that will be defined in a workload definition, which is technically a infrastructure definition, but that's only one file and very, very limited number of code. I think it's probably 10 lines of code or something, right? So as we can see by definition of how this supply chain and Cartographer is structured, it's modular and reusable right then and there, and it's event driven. It does not require, does not have tight integration with source code because I'll explain that when I'll demonstrate it. And hence it can scale exponentially, right? So the number of repository or number of application or source code does not necessarily will lead to increasing number of supply chains, because it's selection based rather than tight integration to a source code repository, right? And in the demonstration section, it will make more sense. Then we are getting rid of the Docker file by using something called kpack, which is the Kubernetes implementation of buildpack.io. And that does not require a Docker file. In fact, that buildpack is more secured than writing a Docker file. So I can get rid of the whole Docker file overhead by using something like buildpack. No handover is needed, because in this case the operations or the definition of the supply chains are completely happening in a segregated manner. It does not have any direct dependency on the dev source code, and we do not need to add any infrastructure definition file in our source code repository at all. And it's cloud native, so everything is running within Kubernetes. So that means if Kubernetes secret gets rotated, that secret will it'll reference to those secrets, and that's how it's automatically rotated for this. So I'm not storing the secret in a third-party tool. It's actually within the platform itself. So this is how we can achieve the ultimate supply chain scenario. So now I'll get into the demonstration part and showcase like what's the problem and how supply chain kind of solves it. So let's explore the problem statement that I've specified here. So how it actually creates a problem. So here I have my source code. This is an application that I've been working on. Very simple application, just a Spring Boot Java application that has got a controller, and when I hit the endpoint called health check, it will recite that I'm running. When I say do the endpoint /do, then it'll send everything which is in the environment variable. So pretty simple. And I've written a Docker file, which is a very simple Docker file called Maven, because I need to build it. So it's a build Docker file, build and run eventually. So I'm getting it from the Maven base source image, and then I'm getting the jar file is getting built, and once the jar file is built, it's just running the jar file, right? Pretty simple. So now, if I want to create, let's create the dev pipeline, right? So what that means is I need a Jenkins file for it. So let me bring in the Jenkins file. Okay, so that's a Jenkins file where, because my Jenkins is running in the Kubernetes, and I'm going to run a pod. So what's happening here is get the URL, get the source code, test it, then package it, then Dockerize it, and then once the Dockerizing is complete, then deploy it. Now notice that this is hard-coded. I did not have any other way of doing it, but this could be environment variables. It does not have to be hard-coded, but there is Kubernetes secrets that's involved in here. So this is the problem statement number in the security hole that I was talking about. So in Jenkins, what I need to do, I'll go in and create a new pipeline. And I'll name it, let's say, demo app dev pipeline. I'll say this is pipeline. Okay. Yeah, of course. Okay, so I'll try again. So I go creating a new pipeline, and let's call it demo app dev pipeline, say this one, and then I'll skip this one, pipeline from SCM. So it'll be like in the SCM is git, and the repository URL is the same repository URL because that's where we have our Jenkins file. I could have placed the Jenkins file in a different repository, but then that would mean every application needs every application repository will need to have a parallel infrastructure repository with it, which is again a massive overhead. So I go, that's okay. Should have credential there. So here I will select my credential, and then this will be main. As Jenkins file, I'll save this one. Right. So now I have that pipeline. That's just pipeline number 1, right? Now let's say I run this pipeline and everything goes according to plan and everything is smooth. So at this time, I'm ready to deploy the application onto staging environment, right? So this time let's say prod environment in this, for argument's sake. So what will need to happen is first I need another Jenkins pipeline. Which will tell me, like, because if you remember the prod environment or the staging environment here, then I need to run security scan. So another Jenkins file that comes in and which has got the scan source, then there is scan image as well, which is somewhere here. There you go, scan image, and the pipeline kind of starts to getting a little bit complicated here, right? But that's okay. We can still use this one. However, there is one problem that exists that which is the Docker file, right? And you will see that in this, according to this diagram, we need a secured Docker file. So that Docker file actually looks something like this. So let me bring that in as well, which is Docker file prod. Okay, so now here, so it's not, so I'm going to build that from the same Docker file that I used here, so that's fine. So that's my build image. Then I'm going to use the Ubuntu Bionic, which has got less CVEs, so it's approved by my organization and so on and so forth. But this is a clean image, so that means I need to install the OpenJDK on it, the JDK and the necessary binaries too, in that on that OS, so that Java application can run. And then, yeah, so there's a bunch of things happening, and then slimming it down, and then bringing that build jar file, and then exposing it, right? So that's the long as Docker file I was talking about. So far I've got 2 Jenkins file, 2 Docker files. If there are more environment, I may end up having more infrastructure definition with the combination of Docker files and so on. So I'll quickly create the demo app prod, for example, because I already have received. So the app operator, when they will supply me this Docker file, will also supply me this Jenkins file and this Docker file, will, according to following this path, is they will also create the staging pipeline, right? So in this case, we're just calling it prod. So this pipeline script will come from SCM, and it will be git. The repository URL will be the same one. which is this thing here. So that's the repository URL. Again, the credential will be this. Oops, that will be the credential. Okay, and this will be on the main branch. It's not a best practice, but anyway, just go. It's okay for example purpose, and the name of the file is called prod, right? If I'm not mistaken. So, and then I'll save this pipeline, right? Now, if I run it, it should use that Docker file prod is actually defined in that pipeline, right? So that should still be okay. I think it's somewhere it's mentioned Docker file prod. There you go. So that's how it's going to build the application and then deploy it. And along with that, this time I've also supplied a bunch of Kubernetes files, right? which is the deployment.yaml. And the preparation might have happened. There needs to be service account, there needs to be route opened, and so on and so forth. This is a very simple one. Still 36 line, but if there were ingress controller associated to it, so that means there will be more Kubernetes code. So as you can see, this picture starts to get very complicated, right? So the point that I was highlighting here is that we cannot scale. So if there is more, let's say I start working on another application, that would mean that in the Jenkins pipeline or pipelining tool, I'll have to create 2 more or 3 more pipelines so that I can deploy the application onto the target environment. Few other security holes that's associated in here is I'll actually have to maintain all of these credentials, right? And that's not great. Like I still need to add 1 more credential, which is the authorization of Jenkins robot that I mentioned in the pipeline, which is here. So this actually means that I'll actually I'll need to use that secret to create that credential in here, and when the secret will be rotated, I'll need to come here and update that as well. So either I could do it in an automated manner, or I could do it manually. Most organizations will do it automatically, but it's still, that's an additional extra automation that I'm creating that didn't need to be created. So I hope with this the problem statement that I was mentioning here is pretty clear. So next up, I'll switch on to demonstrating Cartographer. If you haven't watched the previous segment where I described the challenges with traditional orchestrated pipeline and how Cartographer supply chain solves those challenges, please go watch that segment. In this segment, I am going to focus on installing enabling Cartographer on a Kubernetes cluster and creating various templates, as we can see in this diagram, and supply chains, so we can deploy our application through that. And we're going to use only 1 workload YAML file to target one at a time supply chains without having to change any infrastructure definition in our code. So without further ado, so let's get cracking. So there are the Cartographer, the SH, that's the documentation. You can go read more about in that page. I'll quickly open it. I'll quickly open the link here. So that's the cartographer.sh, and in order to install Cartographer, we first need to, I'm going to use Tanzu Community Edition's package repository. If you haven't seen that one, it's pretty handy. A lot of packages that comes out of the box from that package repository. So that is in Tanzu Community Edition. We go in there and I can look at that's the Cartographer package that I'm going to, that Cartographer tool set that I'm going to use. This one has got a couple of dependencies, and this the package repository also has something called App-toolkit. So that's the one I am going to utilize so that I can get a few of the dependencies installed all in one go. So basically, the packages that I am interested in is the App-toolkit package here, and it describes what's inside that package. So all of these are the dependencies to run Cartographer and Knative. So there are a few things that is extra in here. You don't need that for Cartographer build clusters, but in this case, to keep it simple, I'll install the entire App-toolkit. Yeah, so it has got the instruction how to go about it and what to write and so on and so forth. What I am going to do is I'm going to use a shortcut using Merlin. So I'll just quickly to Merlin, and the wizard that I'm interested in is this one here. Okay, so I'll just do git clone this guy. Done. Okay, so I'm gonna go inside the wizard, and the couple of dependencies prerequisite that this wizard has is basically Docker CE. So I've already have Docker installed. So I go Docker. Is this the one version? Yes. So I've already got Docker installed. So that's one cleared up. So I do not need that because I'm using App-toolkit. If I was using Tanzu Application Platform, which is a commercial version of it, I would have needed this. Most of the things I do not need for App-toolkit. Okay, so .env file. So this file basically contains a bunch of definitions. So something like, so there are a few things that this file contains. For example, I will not need any of this. I will not need any of this. Only I will only need this section here. So I've already prepared the .env file. So I'll just get that. .env. I can't show this file because I've got a few secrets in there. So there you go. So now I should have. Okay, so I have .env file, so that's sorted. And in terms of binary, that it needs the TCE binaries. This is mentioned here, so I'll just get that as well. So that one needs to go under binary section. So done. What else? Oh, and it needs to connect to a Kubernetes cluster. So I've already, I already have a Kubernetes cluster running in my cloud. So I'll just get the config file for that, which I have here. And it needs to go under kube directory. That's it. So I can just start. It is going to prepare the environment for me. It's now installing Tanzu Community Edition as well. Okay, so while that's going, let's have a look like what I need to do. So I need to first add the package repository from the Tanzu Community Edition, which is the URL I just showed. And then I'll need to deploy the App-toolkit. So this package here, this package here. So I need to deploy that. And then I can get going with creating Cartographer templates. So I'm going to create about seven different templates, and I'm going to use all of it. Purely because I'm creating 3 supply chains, one for just dev scenario, where it is as simple as getting the source and run a test. Of course, we need to run that. I could omit this, but I'll just have it in here. Build image and GitOps. So basically, pretty much replicating what's showing up in this diagram. So if we look at the build, test, deploy scenario, so I've got source provider template, source tester, image builder, and image deployer. So instead of image deployer, I'll use GitOps. And then when it's build, test, scan, and deliver, we're just going to use 2 more templates, resources scanner and image scanner. So I'll create all of that as part of this demonstration. Okay, so now this is all running. I'll just double check a few things in here. So Merlin is now ready, so I'll just clear the screen. Okay, so if I see Merlin help, so these are the options available. Let's double check if I have access to the cluster. Namespace. There you go. So I have access to the cluster, and it's a fresh cluster basically. I already have Tanzu package repo because this is a Tanzu Community Edition Kubernetes cluster. So I have this already installed for me, but I still need to add the TCE repo in here. Okay, so what do I need to do? So note that I need to create the App-toolkit first, which is this thing here. Install App-toolkit. So I'll go Merlin, install App-toolkit. We'll check whether I'm connected to the correct Kubernetes cluster. Yes, I am. So that's it. It tried to find the App-toolkit package and it says it's not there, so it's going to install the App-toolkit package. So TC, it's not going to install the repo first. Okay. Okay, so I'm going to install the App-toolkit now. I'll say yes. So now it is going to install the TCE repo, the package repository that contains App-toolkit. Throws this throttling error, but that's okay, I can safely ignore that. Okay, so as I can see, the package has been installed, the TC repo has been added, and now it has gone into, it has found that the version 020, which is this version here, of App-toolkit exists, and now it's going to ask for a few variables that I need to supply. so that it can install the App-toolkit. So these all processes are all documented here. All Merlin tool is doing is automating that. So I would like to create a load balancer, and the domain name, I think I've got a domain name here, which is, let me quickly double check the domain name. Okay, so my domain name is, let's say, exp.xyz. That's my domain name, so I'll give that one. KPAG default registry. So this is going to be my registry. And I would say this is it 1, 2. So that's the registry. Docker username is, that's my username. So it's just asking for a file name. I'll give is it 1, 2, 11. So same name as my Kubernetes cluster. So I can later on look it up. So now it has created the values for the YAML file. So basically that looks like, so I can just go in. So I just go in that direction, and then that should be in the configs. There you go. That's the value that I'm looking at. So that's the value that it will supply. And then I could say yes. So that's the same values.yaml file, which is written in here. So I'll say yes, I would like to install it, and now it will go ahead and start installing. So it will create the credential. Say yes. So that's basically, although like this example uses creates a registry credential, so that's what it has just done. But I'm not going to use it, but it's there if anyone is using Merlin toolkit and wants to install, wants to use exact same credentials. The credential will be created there. So this thing will take about 2 to 3 minutes. So I'll come back. I'll pause the video. I'll come back when the reconciliation is finished. Okay, so the package reconciliation package is now installed. So if I increase the size of it, okay, now it's better. Right, so it's now all reconciliation succeeded. So let's just quickly recap what we just did. So according to our plan, we need to enable Cartographer on Kubernetes cluster. So we added the package repository, and we installed or deployed, whichever term that you want to use, the App-toolkit from the community edition. So this part is now done, completed. So the next step is create Cartographer templates. So yes, I can see the reconciliation succeeded. That's done. So now let's see what Merlin can offer. So it has a section where it creates Carto templates. So I'm going to use this wizard. Clear this space. So now I can go and create Merlin Carto templates and hit enter. So it tells what it's going to do. So it's just going to ask for a file name. So I'll just give it, is it one Carto 11 values? Okay. So now it's going to ask a series of questions, right? Source pool. So it's asking for this template here, source pool. So I'm going to say yes, I'm going to create it. Maven test, yes, I'm going to create it. Source code is scanning, yes, I'll create that template. Image build using kpack, yes, I'll create that one as well. Image is scanning, create that. This is using Trivi, so I'm going to create one with gripe. So I'll skip creating the Trivi one, so I'll say no. Knative service, yes. So this is it will generate a config with Knative service, which is this part here, GitOps, and then it's going to create a writer to write back into the Git repository for GitOps purpose. I'll say yes. So it has done that, and now it's going to ask me a series of questions. The service account name, so I'll say Carto SA. The service account doesn't exist yet, so the wizard will prompt me for creating that as well. I'm going to create it in the default namespace. Master template name is source, Git secret name, right? So this is the one where the source template needs to know how to access the Git repository. So it's asking for that. Git repo secret. So that's, we'll use that. 60 seconds is fine. So every minute it will poll. And then Carto rest template name. So this is for the test one. So I'll accept the default value as test. And now for the test run, it's going to use take-on task. And what type of task it's going to be, so I'll say this cluster task, and the name of the task. So this is test, I'll say Maven test task. Gripe template name, source the scanner. In order to run gripe, it's again going to leverage a take-on task for it. So I'm going to use the name gripe scan task. Oops. And that should be it. Carto gripe registry secret. So it needs to understand where it's going to pull the image from in order for gripe to scan. So this is, it's asking for the registry secret for it. So I'll just go private registry secret. So now the secret still exists. Like, I'm hoping the wizard will prompt me for it. Just check the spelling so that I don't fat finger anything. Gripe config secret name. Right, so it's asking for, so I'll just say secret name is gripe config. And this is to supply the scanning policy. I'll supply that in form of secret. The image template name, kpack image is fine. Image prefix. So, and it has got the hints as well, so you can read the hints and figure out what should be the appropriate value for it. So in my case, I'm going to upload coding. I'm going to upload to my GitHub GitHub registry. So that is going to be this. According to Ali, yes. I'm going to create a kpack builder cluster, cut image kpack builder name. Right, so I'm going to use the default kpack. So it's going to, so the way I have gone about it is, in order to build the image, I'm going to use kpack. So according to this diagram, so That's the buildpack.io, and kpack is the Kubernetes distribution for buildpack.io. So I'm going to use that, and that's this settings are about, and I'm going to use kpack service account name. Okay, so now it's asking for a kpack service account. Now I could go with the same service account, but I'd like to keep this separate. So this one is going to be kpack SA. So the reason behind this one is the Carto SA will have the necessary roles and permission associated to it, versus the kpack SA is only going to be holder of secrets. So kpack knows how to connect to the Docker Hub registry. So select that. Template name is image scanner, sure, and then it's asking about the knative config writer template names. Yeah, config, I'll accept the default. Image pool secret name, so same secret name as I used before. It's PVT registry secret. Then Carto git writer template name, so accept the default cluster task. It's going to leverage Tecton again to write back a little bit. So I'll just say git writer task, and SSAs. It's a secret name, so I'm going to use git SSA secret. So that's good. Git writer repository. So now it's asking which repository should it use to write back the deliverable. So I already have a deliverable repository, so I'm just going to give that URL to that repository. So this is a different repository. If you're not familiar how GitOps works, it's basically you have your source. So it's basically this side here. So for example, once Cartographer finishes, like testing source, building the image, it will produce a config file that will be written in another Git repository, and that repository then will be used to delivery from there. So it's basically I could go with Kubernetes deployment YAML file that way. So what this is doing is generating that YAML file automatically. So I'll use that. Branch name, I'm just going to use main because it's a different repository. Git writer username. So my username is going to be this one. Git writer email. It's going to be let's just say Carto at cluster.com, and commit message. So when it writes back that config file into Git writer, what would be the commit message? So I'm just going to say demo Carto commit. Okay. Kubernetes service account, image pool, secrets. So now it has gone ahead and it's trying to create the service account that I said, which is service account Carto SA, and the service account name, it used Carto SA, and the image pool secret. So it's going to associate the image pool in there anyway. I don't need it, but I'll mention it just in case. Private registry secret. Okay, and I'll say I don't need it more. It's done. I'll add the git secret in here as well, which is private git repo secret. That's I only have one. It is now creating the Carto SA, and it's going to create the role binding associated to it. Again, all these things are already documented, so I'm just going to, all Merlin is doing is just automating it. So it created, it says file generation complete, review and apply, apply then in the connected Kubernetes cluster. So what it's mean is it has now generated this file here, which is the SA, the Carto SA file, service account file. So if I look at the content of it, it's pretty simple. As I mentioned, all Merlin is doing is automating the process, and it has also generated the bunch of templates file. So that's the templates file that we're going to create in Cartographer. Okay. So I'll say yes, and it will just going to go ahead and add those in here. So all done. Now what it is doing is it detected that there is a git SSH secret, and it is asking confirm yes to create a new one. It's asking like, do I have a identity file to create that git SSH? I don't have, so I'm going to create a new one. Email address is again going to be carto@cluster.local. Email address doesn't have to match, it is filled because the public file. So just do that. It will generate the key pair, and it tells me what to do here. So it's given me the public file, which I need to go ahead and add in the GitHub repository. So what I'm going to do, I'm going to add them in my Git repo right now. So the same repo for the GitOps operation. So which is this repo here, and I'll go add deploy key. So it expects a that public key file, and in here I'll mention what Carto. Oops, GitOps. Okay, I'll give it write access, and I'll add this key. Done. So now I come back to this one, and I go yes, confirm, create SSH key. It's asking for the hostname, which is this guy here, and I'll say yes, that's my hostname because it's GitHub. In your case, if you're using a enterprise one, then the hostname will be the enterprise one. And it's asking for a file name, so I'll just go git SSH. Okay. So it's for the GitOps secret name, so the same one that I mentioned there, which is git SSH, I think. So the one that I mentioned during these settings, git SSH, so that's the one, so I'll mention that. Now it's going to create that git SSH, so it's done that. Okay, so now it's saying this wizard implements Cartographer process using text on task. So text on pipeline, the text on CD is not installed, so it's asking whether I'd like to install this. I'll say yes, I'd like to do that. Because this is a fresh cluster, I don't have it installed. So I'll just go ahead and install Tecton. So Tekton installation complete, and remember, like I mentioned, like I was going to create a Maven test template so that I can run Maven test using Tekton task. So it's asking like whether I'd like to create that task now. I said yes, I'd love to create that. So it will be the same name that I given before, the Tekton task name. So Maven test task. So that's the task name that I given before. So it will create that in this directory. And now it's asking for Tekton task for writing to Git. I'll say yes, I would love to do that. And this was, I think, gripe scan task. Let me double check. So here, gripe scan task. So that's the task name that I've given before. So I'm going to create the task with that name. And now the oh, I've just made a mistake. So this one was for Git writer, not gripe scanner. Oops. This is gripe scan. So not to worry, because all it did is it created the task as well, but that's okay. So I could just go in here and I can see that's Maven. That is Git writer task. So this file here. So I could go hello Carto Git writer Tekton task. So that's why I've made a mistake. So it should have been Git writer task, right? But before I change that, I want to ctl delete -f Carto Git writer Tekton. So I'll delete this task. And then I'll change the name because I made a mistake there. Should be Git writer task. That's the name that I've given. And now I can go apply this. Apologies for that. But yeah, these things can happen. I can make mistake. And even though I make mistake, there is a way to fix that anyway. It's pretty flexible that way. Tekton task for gripe scanner. Okay, so now it's asking. So now this is the name. This was wrong, which I just fixed. I go gripe scan, and it's going to create the gripe scan task, which is great. And now I would like to create secret private registry secret. So it identified that somewhere along the line I specified that there's a secret named this. So now it's asking me to, it's going to be a Docker Hub image registry secret. So it knows that. So not Docker Hub. It's going to be image registry secret. So I'll say yes. And Docker registry server, which is going to be this guy here. That's my server. My username is done, and it's asking for a password, which I will now provide, which is this password here. It's okay, like this is a Docker Hub token, which I'm going to delete after this video anyway. And I'm going to create that in the default namespace. So now I created that. create secret private Git repo. So it also identified that I had also mentioned a Git repo that I would like to access using this secret. So it's asking whether I would like to create that secret. I'll go yes, I'll have to do that. The file name is going to be, let's just call it pvt git repo. Let's call this git secret. And the server is, in my case, it's GitHub, this server here. Okay, so that one. Username is, this is my GitHub username, and the password is going to be the GitHub token. So I'll use token, which I will delete after this video, so no problem if I expose it in here. Then the namespace is going to be default. So it's now creating that secret as well. What else? Image registry is associated with image registry, kpack service account. Service account. Yes. So Docker registry name. Actually, this one I may not be needing it because I already have created the image registry secret. So I should have said no in here, but the wizard has gone into creating a secret mode, so I'll just play around. I'll just say according to Docker registry server is this guy here. Okay. Username. So this is just going to be, I'm not going to use this one. And password. I'll create a real secret, but I'll delete it afterwards. So again, this is my mistake. I made a mistake. I should have said no in here. But even though it's just going to create an additional secret in here, namespace. So I'll just create Docker registry secret. Create a service account. So now it has gone in saying, would I like to create a service account? So I say, yes, I would love to create a service account in this case. File name, kpack sa. As an image pool secret. So remember the secret that I created, which I said I created in mistake. So it's now asking whether I'd like to associate it, but I've created another secret anyway, so I'll use that one, which is registry secret. Service account, I don't need to add any more, and I will add the git repo secret, and let's just one of that. So done. So if I now the wizard kind of walked me through creating all these templates and that needs to be applied, and then it also created the secret. So I'll create a map and showcase like what just happened here. So if I do kubectl get secrets, I'll see that there is this secret that exists, which we created. Then this one exists, which we're going to use. This one exists, which we don't create accidentally, so we don't need to use that. So I'll just do ctl delete secret. Okay. So done. And if I go kubectl get service account, then I will see there's two service accounts. There's Carto SA, which has got the role bindings, and kpack SA, which is I'm going to use for image building purpose. So this one. So basically, the explanation here, what has happened is this template is going to use kpack, and kpack is going to build image looking at the source code, which we already know. So after it builds that image, it's going to push that image onto the container registry. So in order to do that, it needs the secret to access this registry, and it does it through a service account, which is the kpack SA that we just created. The Carto SA service account that we created, that's basically because only for so the Cartographer itself, when I create the supply chain, where I'll use that service account, so it can create detect on task, and it can monitor those tasks. It can create a pod and so on. And it will make sense when we'll run a service account. So now the template setup is complete, right? So let's have a quick recap. So in here, we said Cartographer templates. We created all these templates and we sort of wired it with our secrets and everything. So this job is done. So now at this point, my Cartographer is platform is ready to get used. So all I need is the supply chain to create. So I'll create this one first. So the way Merlin can help me do that as well is if I go Merlin help. So it has a supply chain wizard as well. So I'm going to use this one. Excuse me. So it will be Merlin Carto supply chain, and now the supply chain file name. So I'm going to call this supply chain dev supply chain. Okay. And then it's asking like what are the things that I would like to associate with this supply chain. So one is obviously the Git repository. So that's going to be the source provider here. So I'll refer back to this diagram. So this one, so this supply chain. So I'm going to create this one, and it has got association with this, association with source tester, association with image builder, and instead of deployer, I'm going to use the GitOps. So let's create that. I'll say yes, Git repository. And then would you like to add test to the supply chain? I'll say yes, I would like to add test repository. And then scan. No, I'm not going to use the scan right now. An image builder. Of course, I would like to use image builder. And scan image. No, I don't like to. I don't need scanning right now because it is a dev supply chain. And for GitHub operation, config generator, yes. So I said like I'm going to use GitOps with this dev supply chain, and say yes. And instead that commits git writer, yes. So git writer. So now the config is going to be created by this step. And this config needs to be pushed. So I'd like to use git writer template to do that. So now it's asking for supply chain name. So I mentioned before, it's going to be this one. So workload selector. So this is pretty interesting. So in my previous segment, I mentioned that this is all loose coupled, and the way the supply chain picks up which source code or which repository to process is through a selector. So it will make sense when I'll write workload. So for now, what I will do, I'll just say this is for workload type. So this is the selector works based on tagging. So in this case, the tag. So I select one tag, and I will say this supply chain doesn't have security baked into it, so instead of security I'll just go simple. Okay, and that's it. So that's the selector. Account name, so this is going to be Carto SA, the account that we service account that I created before. Template name, source, yes, I can call that source, that's okay. I can call this one test, kpack, source provider. So this is the dependency, right? So the image builder should come after the test. So not source provider, instead of source provider, it's going to be source tester. Okay, if I was just doing source to build, then this one should have had the dependency in here. But instead, I want to run the test, and if the test passes, only then I want to run the image building. So that's why the reference now in here. So I'm just wiring the supply chain, right? So this is how I can flow from which the event should arise and who should listen to the event and take action. And then from the config writer, I'll just say, yes, that's fine. And dependency, so I'm going to write the config after the image building is finished. So image builder is fine in this case, and git writer, and then it created the supply chain. So let's have a quick look at the file for the supply chain. So the file would be, so it created the supply chain file, which is this guy here. So that's as simple as this one. So name of the supply chain, that's the selector. So whichever workload will match to this selector, the supply chain will run from that workload. And workload is actually a definition of this application itself. So we'll see that in a second. Service account is Carto SA. It exists in the default. And this one is independent, so it will start from here. And then I can see that the test is depending on this one, the source getting finished. So once the source will raise the event that, hey, I am finished, here is the URL, then the test would run. The image builder is dependent on the test. So here's source tester, right? So when source tester will finish testing, the image builder will then run. And rest of this stuff follows the very same pattern. So that's how you can sort of create the steps like one after another. If I was doing image builder from source provider, so that means the source tester and image builder would have run parallelly. So this is another advantage of supply chain. I can run tasks in parallel rather than the orchestration, which is one task must run after another. So now our supply chain is ready. So now I can actually create a workload. There is a sample. Oh, before I do that, there is one other thing that I forgot to add, which is not needed now, but I'll add it anyway, which is the gripe config. So there is a template that exists. So this one, I'll just copy it into the configs section. Okay, and if I have a quick look at that, so this is pretty much saying, hey, do not scan the Spring core, because I've tested this. For a Spring Boot based app, there is a false positive that gripe returns. So this gripe config, this section is actually gripe policy. I would instruct gripe what to scan and what not. So I'll just apply this one. So now that secret is created. So that's done. Okay, so let's quickly recap what we have just done. So in here, I created this scenario. So I created a supply chain, which will take git source, will test, build, and it will do GitOps. And now I'll demonstrate how to actually run this. So there is a workload template that exists. Again, I'll get that. It's Carto workload sample. I'll add that into configs Carto section. Okay, so let's have a look. Configs Carto. So I'm just instead of calling it that, I'm going to call it workload dev, or yeah, workload.yaml, just simple name. Okay. So if I now have a quick look what this one contains. So remember the selector I was talking about? So that's this one here. And I used this selector, I think. So let's have a quick look what I used. It's called simple. Okay, so I'm just going to mention it simple. So that means the supply chain that I created, based on this matching criteria, this supply chain will be executed, right? And in here, I have the repository URL. So instead of this, I'm going to give it my sample app repository, which is this repository here, right? So I'll just get this one. By the way, the Jenkins file and all that, that's from the previous example where I was showing this repository here. So I don't actually need any of these files. Sorry, any of the Jenkins files in here. So these files, I don't need any of that. So I'll just simply paste this, and that's about it. So this file can live in the source code, and this file can be controlled by the developer themselves or the engineering team. So that's completely fine. This is what 10 lines of code, and it's very simple. It is technically an infrastructure definition file, but because this is such a short file, like we can get away having this. Or if there is if we still want to keep this one completely segregated, because this needs to be applied only once, right? Which after the development, as soon as the development starts, we're going to know like what's the source repository for it. We can instruct the operator, hey, there's a new project that is started, please create a workload for it. And the operator can go in and create that file and keep it in their repository instead of mixing it with source code. Either way, this is a simple file. And if I just apply this file now, so now that should trigger the supply chain. So I could watch kubectl get pods, and I should be able to see that the pod will start to come up. So you can see the test has it started running, and then it will, after the test finishes, it will build and yeah, it will continue building and creating deployable for this workload. So I could quickly see is using kubectl tree command, and the name of our app, which I completely forgot. So let's have a quick look. It's called demo app, right? So that's the name of our workload. So I could see what's happening here. So I can see that it pulled from Git repository, so that succeeded. Test is going ahead, and the next step after test we added is the image build. So if I keep watching the pod, I should be able to see the demo app build pod has come up. So the build task has started. So I could look at the build log, which is going to be kp build logs, and the image name is going to be, I believe, demo app. I could see what's happening here is it is going to detect what sort of workload it is, and then it's going to select a build pack for it, which is going to be based on a JDK build pack, and it's going to start creating the container image. So this is the one that I explained, and no Docker file is being used in this case. So this is the one that I was explaining how we could get rid of the Docker file overhead. So remember the Docker file overhead we talked about, so how we could get rid of that. So that's demonstrating that part. And the build will finish, and it will push that onto our provided image registry. So it's going to take some time. What I can do is, while that's happening, actually I'll keep monitoring this, and then I could kick off creating another supply chain and redirecting our workload onto that supply chain. So without having to change anything in here. So pause the video here, and I'll come back to it when this will get finished. So you can see this task is finished. So this is now completed and build successful, and it has uploaded to my Docker Hub registry with this tag in here. But I don't have to know this tag, because it's also going to create the deliverable that I need to deploy in order to deploy this app. So all that manual config writing, that kind of goes away. So now Git writer, so Git writer has started, and it has written the task, and it has completed as well. So what I can do now that it's completed, so I could go to my deployable, and I could see that a commit has happened just 29 seconds ago from the supply chain. So I could go in here, and I could see the manifest file. So this is the file that's going to get deployed. So this file has got the image that's going to get deployed. So the image that just got created. So this image here. And this is configurable. So this is what I created, right? When I defined that config map templates. So which is here. So if I go, let's Carto, I think it's called knative config map. So I've defined the template, how that application is going to be deployed, and I use Knative for it, just to simplify life a little bit better. But this could have been a simple Kubernetes deployment as well. So now that's complete, what I'll do, I'll create my second supply chain. Right. This time I'm going to call it secured, and this supply chain should have Git repository test scanner, okay, image builder, image scanner, config writer, definitely, Git writer, yes. So supply chain name is going to be secured, and the workload selector, so in this case, I'm going to use both of them for the supply chain. So I'm going to tag it called secured. Right. Service account name, same stuff. Carto SA, call it source, call it test, call it source scanner. Okay, so now the dependency in here is going to be source tester as well, the same as before. So this is the source scanner, right? Source scanner should run after the source testing is completed, or I could do it even before, or I could do it in parallel. Actually, let's do it in parallel. Okay, so source provider. KPack image, it's fine. The image, I definitely want to run after the scanner. Okay, because if the source scanner detects any vulnerability in the source code, I don't want to produce an image. So this is going to be image scanner, app config, and the image scanner and the image build of the config provider, sorry, should have the dependency on image scanner, because if the result of the image scan detects a vulnerability, I don't want to produce the deliverable for the GitOps operation. Okay? I know that Git writer, everything else is the same, and it just got created, right? So now I could just delete my old workload. I could keep it running because that's going to trigger the existing supply chain, but for demonstration purpose, I'll just delete this, delete workload, demo app. Okay, and now fix so workload. So this time, so imagine now in my scenario, the build path is now all good. Like I have iterated many times, and I'm satisfied with the build. Now I want to put it into staging, right? So that's where it will start. And what I'm saying here is, hey, supply chain, use this path instead. So the way I could do that is, instead of using simple, I will match it with the supply chain that got created. Right? And there could be many other workloads that will have the same matching. So that means for all of those workloads, it will be the same. It will be the same supply chain, which is this guy here. So I don't need to create another supply chain for another application. So now that's done. And if I do keepctl -f, my workloads, not deploy, sorry. So now the workload will get created, and the same as if I run kubectl get pods minus, also going to be in default. So you could see, watch. So now, here we could see that the scanner and the test has started running in parallel. So that's what I was saying, like on the dependency, right? Because both are dependent on the source. So if I do kubectl tree workload demo app, I can type faster than it is processing. So I can see the scanner and the test are running in parallel. So that's one of the beauties of using a event-driven architecture, right? And we are solving multiple scenarios here. We're solving multiple scenarios here, right? So if I quickly, well, that's happening. If I quickly recap the scenario, the problem statement that we specified in here. So one, we need to achieve event-driven architecture. So what we have achieved using SupplyChain, it needs to be modular and reusable, and we discussed how the master template may not completely solve that problem. It is a step forward, but it's not going to. But in SupplyChain, what happened is every stage is a template itself, and any supply chain can use that template, right? So it's one level up from just master template. Infrastructure definition from our source code, so dev and ops should be completely segregated. So as we saw in this, except for that workload.yaml, which may or may not live inside the source repository, it's completely segregated. The Docker file we removed it using buildpack, which is great. So that means I don't have to maintain the Docker file. The YAML file, I've removed it as well, because the supply chain is now producing that deployable YAML file, so it doesn't need to reside in the source code repository anymore. The handover process is practically zero. So except for that workload YAML, which can be a handover thing, but it doesn't have to be. It can live inside source code. It's just 10 lines of infrastructure definition, right? That is still significantly better than this process here. And the security problem. So as I was wiring up the supply chain with necessary secrets and all, these are essentially Kubernetes objects. So that means if I just, when I rotate the secrets across my organization, if I just rotate that in Kubernetes itself, I don't have to maintain it in a separate tool set. So that scenario is also resolved using SupplyChain, right? So what we had just done in here is we created a secured delivery supply chain, which is this thing here, and the test is complete. So the scanner has run into an error, right? So I can see, so something must have failed. And I could see CTL logs, and the supply chain stopped. So let's have a quick look. The test completed, but since the source scanner stopped, so the supply chain did not move forward. Okay, so now we can see that it has detected a vulnerability in the source code, which is a false positive, but it has detected this vulnerability, right? So it stopped the supply chain. That means what we wanted to achieve is actually happening. So the way we can fix this is for this demonstration purpose, I will Carto scanner thing source. So this one, I will just add, I'll instruct gripe not to halt it. So I think the parameter is args, and the value is going to be by default. The argument is fail on critical, right? So I'll just remove that argument for now. I could also create a separate gripe config, so that is also fine, but I'll take the shortcut for demonstration. And what I'm also demonstrating is I'm not going to change any of the supply chain. I'm just going to change the component that's doing the sources scan, right? I go keep ctl apply -f Carto scanner source. Okay, so now I've changed that component, which is this component here, and I haven't touched the supply chain at all, right? So everything remains the same. I just fixed or changed one component. And now what I can do is I will keep on watching again. So this was what errored out, and I will do a git push. So let's just modify the readme file. Okay. Let's say something to add, and then I'll add commit message is update read file, and add it to trigger supply chain, right? And then I committed this change. So now this commit has happened. I'll wait maximum of, oh, there you go. So now it has started. So if I look at keep serial workload, I can see that this just is this just is started, or this will start again, and it will create. So we said the interval is 60 minutes. So which is Carto cluster source template. The standard is so the interval, poll interval is 60 seconds, right? So I'm going to wait 60 seconds, and that should trigger the scanner. Here we go. So that now just got triggered. So now it's going to run test and scan at the same time. The scanner will come up pretty soon. So here, so this one. Now the scanner is running and test is running at the same time, right? So if I go workload again, we'll see that it has started 30 seconds ago. So we'll watch. So now the scan and test both succeeded, and it has gone ahead and it started building the app. Right, so app building is completed as well, because I only changed the readme file, so it didn't go ahead and do a full build. Instead, it's just changed one layer of it. So that's another efficiency gain by the builder. and then the image scanning will happen. So this is the old one and new one coming up at the same time. Okay. So it's going to take some time, so you can see the pods that's coming up and builds that's happening. Basically, this one is the one that errored out previously, and this is the one that just finished scanning source. Okay, and the test just completed 2 minutes ago. This is the previous test. By the way, like all these logs that does the activity and everything, if you want visibility, like it gets appeared as like Kubernetes log. So that means we can view it through our monitoring tool, and we can have alerts in our monitoring as well. So it kind of streamlines that way rather than trying to switch back and forth between a CI/CD tool and the monitoring tool to see what happened in the CI/CD process. So I'll wait a couple of more minutes to get the config written in the deliverable repository for GitOps. Okay, so Git writer just written 73 seconds ago, so that means the new image got written in our deliverable. So this was 18 minutes ago, so if I refresh that, so that's just 1 minute ago, a manifest written. So this is the new image that got written to it. The final piece of the puzzle, so now all of that is good. The final piece of this puzzle is creating the deliverable, so this side, which will actually deliver what we have been building, right, out of these two supply chains, or one of the supply chains. Right? So I'll create a deployment supply chain, which is this guy here, which is again quite easy using Merlin. So I'll just do a bit of cheating here, and we'll create Carto delivery. So delivery name, I'll just say basic delivery. Okay. Delivery supply chain name, I'll say basic. Account name, I'll use the same Carto. Again, like I'm running the delivery in the same cluster, but I could run, I could create this delivery in a different cluster because it's GitOps, so it can pretty much go into any target environment. The namespace is going to be default namespace, GitOps source secret name, so which is private git repo secret. Okay, app deploy. So you should find that it already exists. Delivery selection, I'll just say, oh sorry, workload selection. That. So done, and it should have created a file in here. I could say Carto delivery basic, okay, and under workload selection I have this one and all of that. That's great. The other thing I need to know now, the delivery thing is active, so this supply chain, this guy here is active. All I need to do is give it a deliverable, very same as workload, but we just call it deliverable, delivery.yaml, right? So I have a sample of that. And onto configs. Again, this part doesn't need to be by the developer or the engineering team who is not responsible for delivery. Could be shifted off to the platform team, and this could be also done at the same time. So I'll just do kubectl get pods to see that the application is not running. And now I'll just go nano configs Carto delivery YAML. I'm just going to change this repository. Everything else is wired up to our, so it points to this one here, right? So just take that and paste it. That's it. And I just go kubectl apply -f config Carto delivery.yaml. That's it. And if I watch kubectl tree, I think it's called deliverable. Maybe let's have a quick look. What's the kind here? Deliverable. Okay. So kubectl cannot type faster. kubectl tree deliverable. I think the name was demo app. Oops. Oh, GitOps. The name of the delivery is GitOps. GitOps. Okay. Oh, so it has Git operation succeeded. So it has got the deliverable. And it should do few, oops, not this, it should do a few more there you go. So the delivery already happened. So this guy here. Now that's running. Yeah, so that concludes my demonstration of Cartographer, of how to, so I'll quickly recap. So we have created the GitOps delivery as well. So this concludes my demonstration of Cartographer. What we covered in the demonstration is how to enable Cartographer on a cluster. We created lots of Cartographer templates, primarily the ones that in practical you will need. And we created 3 supply chains, right? So now we can create more supply chain as suitable, which delivers this functionality. So now I can, instead of one application, I can actually scale that to 100 to 50 application of that fits the same criteria. Like, you know, it needs to go through a Maven test process, same build pack scenario, as long as the build pack covers it. So Java build. So I can use just these 2 for all of my Java Spring Boot application. If it's different type, that's where I'll may need to create 2 more templates and 1 more supply chain reference to that template, right? So scaling with this Cartographer supply chain technology is pretty good. I can literally scale to 50 apps, 100 apps, doesn't matter. So thanks for watching. If you have any questions, please let me know. I'll try my best to respond it. Before I forget, there is also a open source. This is an open source project, so there is a Slack channel through which you can get help and or post your contribution to it. The Slack channel, I think, is called /Cartographer. Please contribute. There is also GitHub This is also an open source GitHub project, so you can see it in the GitHub repository as well. Thanks for watching.